Welcome. So today we are learning about factorisation by removing common factors. We're also going to look at factorisation by recognition using the two things we looked at last lesson, which was the perfect square and the difference of two squares. So in our couple of examples, so factorising by removing common factors, we have 6x plus 10. We're going to look at what are the common factors. So in terms of if we leave our pronumerals out to the side, we've got a 6 and a 10. Common factors would be our 2. So our 6x is 2 times 3, and then we've got our x plus, removing our 2 would be 2 times 5. So in terms of, if we bring out 2, bring him out the front, we're going to be left with 3x plus 5. With our second example here, now we've got common factors with our pronumerals as well as with our numerals. So we've got our 5, which is a common factor. X could be just written as x times x. So now we'd actually have a common factor in our x as well. So once again, we can bring our 5x out the front. And what's left? X plus 5x divided by 5x is 1. So common mistake people make is we divide 5x by 5x and get 0. No, because it has to work in reverse. So 5x times x is 5x squared. 5x times 0 would be 0, not 5x. Our final one, which is going to look a bit more scary, we've now got a trinomial. We've got 3 terms. So we've got an x squared, an x, and just a 6. So looking at common factors, we've got x's in our first term, x's in our second term, but no x's in our third term. So we can't factorise by x if it's not common to all of our terms. With our numerals, we've got a 2, a 6, which is 2 times 3, and a 2 times 3. So everything in terms of factors has a 2. So we can bring our 2 out the front. If I take my 2 out, what's left? X squared. If I take my 2 out, what's left? 3x. If I take my 2 out, what's left? Minus 3. So now getting to our recognition. So remembering that a plus or minus b squared is equal to a squared plus 2ab plus b squared, sorry, plus or minus 2ab. And the difference of two squares, a plus b times a minus b is a squared minus b squared. So we have a trinomial. So it's not going to be the difference of two squares because we would only have 2 terms. So we're thinking about, is this a perfect square? So the first thing I do is look at my last term. Is this a square number? Yes. This is 5 squared. Is my first term a square? Yep. X squared. So then my a would be x, my b would equal 5. That would mean this middle term would have to be 2 times 5 times x. Yep, 2 times 5 is 10, so everything's working out. We've got our positive at the end here. Now, is this a positive or a negative? It's a positive. This is our key term, so therefore it's all working out. So we're going to say we've got x plus 5 squared. What about with our second example? Once again, we have a square number on the end. 36 is 6 squared. Our first term, x, is squared. So this number would have to be 2 times 6 times x. So 12x, which it's matching. We've got a negative here, which is our key. Positive at the end. So we're going to end up with x plus 6, x minus 6 squared. Once again, if we do our check, we're should have x squared minus 2 times 6x, so 12x, plus this number squared, negative 6 squared is 36, and it works out. So now we've got two terms. We've got an x squared and a minus 144. Once again, is this number a square number? Yes. So we've got x squared minus 12 squared. Both of these are squares now. So we can relate this directly to the difference of two squares. So it's going to be x minus 12, x plus 12. What about our second? We've now got a coefficient here. We can't factorise by 2. This is not an even number. So we could look at this and say, well, is this actually a square? Well, 4 is a square number. So we could say, well, this is 2x squared minus 9 squared. So directly, we've got a is 2x, b is 9. So it's going to be 2x minus 9 times 2x plus 9. The end.